Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video we covered biasing techniques that we use in JFET. Okay. So in those biasing techniques, we first started with the fixed bias, in which I was using a source or a battery at the gate terminal in order to bias the JFET. Then the second one we saw self bias, in which the gate terminal was connected to the source terminal, but in this case VGS was a function of drain current. And when we apply Shockley equation, we see that if we substitute VGS in terms of drain current, then what will happen? Then there will be a quadratic equation formation from which we will find out the value of ID, and then we will find out the value of VDS. We saw third most popular configuration, which is your voltage divider biasing. Okay, and then common gate configuration. We also saw how we can graphically find out the Q point in terms of DC load line analysis. In this I told you that we have to find the intersection between the load line, but now this load line is obtained using the circuit between gate and source and the transfer characteristic. Transfer characteristic means this is this equation, which is your Shockley equation. So this much we covered in the last video. In this video, we will be starting the AC analysis or the small signal analysis of JFET amplifier. So before studying amplifier, we need to design the small signal model of a JFET. When we talk about small signal model, the first parameter that I will be talking about is transconductance. Now we have seen by means of Shockley equation, what I have told you, that the drain current is a function of the gate to source voltage, or you can say that the output current of JFET is a function of input voltage. So what is this transconductance? It is ratio of change in output current with respect to change in input voltage, which in our case will be del ID by del VGS. Now we know that ID is given by means of Shockley equation, IDSS 1 minus VGS by VP. Okay, also one more thing that I want to tell you here is, in BJT we studied 3 models of amplifier. The first one I told you about the T model, the second one I told you about the hybrid equivalent, and the third one was hybrid pi. If I ask you in which of those model did the transconductance appear, the transconductance only appeared in case of hybrid pi model, which means here also when we will be designing the small signal model, I will be designing the hybrid pi model. So the main advantage when we are studying JFET and MOSFET is that we have only one model for analysis, unlike BJT where we had 3 models. Here only one model will be used, and that model will be hybrid pi model. Now if you want to find out the transconductance, what you will do is, you will differentiate this drain current with respect to VGS. So it will be 2 IDSS 1 minus VGS by VP into minus 1 by VP. I have just used the chain rule here to differentiate. Minus 2 IDSS by VP into 1 minus VGS over VP. Now we know for N-channel MOSFET, N-channel JFET, the pinch-off voltage is negative. So this term minus 2 IDSS by VP will be greater than 0. Now this value is called as GM0, which is mod 2 IDSS by VP. GM0 means transconductance at VGS equal to 0. Okay. Suppose if VGS is 0, then 1 minus 0 will be 1. What will be the transconductance? Minus 2 IDSS by VP. So what we say is GM is GM0 1 minus VGS by VP. Now suppose if you want to plot this variation of transconductance with VGS, GM and this is VGS. So GM at 0 VGS is GM0. For N-channel JFET I know that VGS will be negative, so I will plot the graph on the negative real axis and this value will be VP. Okay. So that is GM varies linearly with the VGS. Now one more relation that I know, ID is IDSS 1 minus VGS by VP whole square, which means I can write 1 minus VGS by VP as under root ID over IDSS. This value can be substituted in the expression for transconductance. So GM is GM0 under root ID over IDSS. Now suppose I again want to plot this graph, that is variation of GM with ID. Okay. This is GM, this is ID. Now if I want to plot this graph, what I will do is, this graph is a square root graph, so graph will be like this. But at most it can go up to IDSS at which the transconductance is GM0. So what I mean to say here is, if ID equal to IDSS, that is the maximum value of drain current, GM becomes equal to GM0. Okay. So it varies as a square root function with the drain current and it varies linearly with the gate to source voltage. Now what other parameters can be used in the small signal model? We will have input resistance. Now we know in a JFET gate current is 0. Why gate current is 0? Because the PN junction is reverse biased. So gate current is 0. That means the input resistance tends to infinity, or you can say open circuit. Is it fine? Similarly, the last parameter when we talk about small signal model is output resistance. Okay. Now when we are talking about output resistance, how can we find out output resistance? If I plot the output characteristics, ID versus VDS, the characteristic was something like this. It is not perfectly flat, but it has a certain slope. Now if you take the slope in this region, this is delta VDS and this small thing is delta ID. So what I'll say, the slope will be equal to delta ID by delta VDS, and this will be equal to 1 by output resistance. So output resistance is 1 by slope, where the slope is actually equal to del ID by del VDS. Okay, we are using partial derivative everywhere because the drain current ID is a function of VGS as well as VDS. So it does not depend on a single parameter but multiple parameters. Hence we have to make use of partial differentiation. Now this resistance is very high. Now when we talk about small signal model, I told you which model we will be using. We will be using hybrid pi model. In hybrid pi model, this was V pi, but in this case we will call it as VGS. Then in hybrid pi model we have a current source GM VGS. Okay, this is the gate terminal, this is the drain terminal, and this is the source terminal. In parallel to GM VGS, we will have a resistance R0. Okay, so that will be the small signal model of a JFET. Here we will have VGS and we will have a current source GM VGS. The best thing about this model is that the gate to source junction is reverse bias and open circuited. So the analysis will be much simpler as compared to the analysis of BJT. But again, our main focus in this amplifier section will be to analyze all the connections just in terms of network analysis without memorizing any formulas. Okay, so shall we start using this model? So first one is your fixed bias configuration. So we have seen in fixed bias configuration how do we perform DC analysis. In DC analysis, we were finding the Q point ID, VDS. Now in AC analysis, what we will do is, we will, just like BJT, we will short circuit capacitor. We are talking about mid band, so all capacitors are short circuited, and we will ground DC supply, which here is VDD. So now if you draw such circuit where you short circuit the capacitor, you have to short circuit DC supply VGG also. Okay, this is VI, capacitor has been short circuited RG. Then this is RD, this is ground. Capacitor is shorted V0. Okay, so that will be the circuit. Now what I'll do is I'll replace the JFET by its small signal model. So how will I do that? This is input voltage. Between input voltage and ground there is a resistance RG. Now this input voltage is connected to gate. Between gate and source we have voltage VGS and it is open circuited. Now this source terminal, this is gate, drain, source. The source terminal is grounded. Between drain and source we have a current source GM VGS. Then in parallel to this source we have a resistance R0. This is source, this is drain. Now between drain and ground we have a resistance RD. Between drain and ground we have a resistance RD. and this is V0. Now these two resistances will be in parallel. So what I can do is I can remove one of these resistances and I can simply write RD parallel R0. Usually R0 is very high, so this is approximately RD. Now this GM VGS current will be flowing something like this. V0 has this polarity, but due to current the polarity induced will be opposite. So V0 will be minus GM VGS R0 parallel RD. From this circuit what I can say? From this circuit I can say that VGS equal to VI, which means V0 by VI is minus GM R0 parallel RD, which is approximately minus GM RD. Again minus sign is coming. Minus sign indicates a phase shift of 180 degree, which means the which terminal is common here? The source terminal is common. So I can say common source amplifier provides 180 degree phase shift. Like in BJT, we had common emitter amplifier which provided 180 degree phase shift. Here emitter is replaced by source. So common source amplifier is providing 180 degree phase shift. Okay. So that is the characteristic of the common source amplifier. Moving on to the next configuration, that is the self bias. Again in self bias I have already told you about DC analysis, that we will find the Q point ID comma VDS, and based on this Q point we will find the amplifier parameter GM and R0. Now when we talk about AC analysis, what we will do? We will short circuit capacitor and we will ground DC supply. So this capacitor will be shorted, this capacitor will be shorted, this capacitor will be shorted, and this voltage will be grounded. Now see, between VI and ground there is a resistance RG. This is RG. VI is connected to the gate terminal. Between gate and source we have voltage VGS. Now due to this CS, the source terminal is grounded. Between drain and source we have a current source GM VGS. This source is connected in parallel to a resistance R0. This terminal is your drain. Between drain and ground we have a resistance RD, and drain is connected to the output terminal V0. Now this circuit is exactly same as your circuit in the fixed bias configuration, which means here also I will write V0 as minus GM VGS. The two resistances are in parallel, R0 parallel RD, and then Vn equal to VGS. So the voltage gain, which is V0 by Vn, it is minus GM R0 parallel RD. Now what about the input resistance of the amplifier? The input resistance of the amplifier in this case is RG. What about output resistance? Output resistance, if you see from here, it is R0 parallel RD, which is approximately same as RD. Even in the previous one, if you find out the input resistance and the output resistance, they will be same, RG and R0 parallel RD. So the analysis of both these configurations is exactly same. Where they are different, they are different in their DC analysis, because in this configuration self bias, we saw earlier that a quadratic equation will be formed, so analysis is not very simple. Now one modification that I'll do is, I'll remove this capacitor CS. If we remove this capacitor CS, it means unbypassed RS. So how will the model change? Now see, this is the input voltage. Between input voltage and ground, there is a resistance RG. This is your gate terminal. Between gate and source, we have VGS. Now between source and ground, there will be resistance RS. See, earlier this RS was short circuited by this capacitor, but now between source and ground there will be a resistance RS. Then between drain and source we will have a current source GM VGS. In parallel to this current source we will have a resistance R0, and here we will have a resistance between drain and ground RD. This will be V0. Okay. So now our circuit has changed when we have considered unbypassed source resistance. Okay. So let us see how we can analyze this circuit. So let me say first I want to find out the input resistance. It will simply be RG, because no current goes here. So that means the entire input current goes through RG. Now let us talk about output resistance. How we can talk about output resistance? It is V0 by I0 when Vin is 0. This current is I0. Okay. Suppose this current is I1, this current is I2, and we have to make Vi equal to 0. Now, what is the current here? The current is GM VGS is coming from here, I2 is coming from here. So this current is GM VGS plus I2. Okay. So now, if you apply KVL like this, so what I can say? Vi minus VGS minus GM VGS plus I2 into RS equal to 0. Okay. Now, if Vi is 0, VGS plus GM VGS minus, if we take it on the right hand side, plus I2 RS equal to 0. Okay, here I have taken the input voltage equal to 0. From here I can say I2 is how much? VGS GM plus 1 minus sign by RS, that is your I2. I have known I2. Now what I need is I1. I1 is simply V0 over RD. But now see I0. By applying KCL I can say I0 is I1 plus I2 plus GM VGS. Now in this case I1 is in terms of V0, but I2 and the third term are in terms of VGS. So how we can find VGS in terms of V0? For that I'll apply KVL like this. What I'll say, V0 minus I2 R0 minus GM VGS plus I2 RS equal to 0. So what I am saying is V0 minus I2 R0 minus GM VGS plus I2 RS is equal to 0. So now here what we can say is V0 equal to I2 R0 plus RS plus GM VGS RS. Now how did we calculate I2? What was I2? I2 was minus VGS GM plus 1 by RS. Minus VGS GM plus 1 R0 plus RS by RS. Okay, that was the case. Sorry, here also there will be RS, that I missed. GM RS plus 1, not GM plus 1. It will be 1 plus GM RS. Okay, so we have this. So from here what we can do is we can find out V0 in terms of VGS. It will get little complicated also here. So let me simplify. VGS, take this LCM. GM RS square minus R0 minus RS minus GM R0 RS minus GM RS square. This gets cancelled. So it will be minus VGS over RS minus R0 plus RS plus GM R0 RS. So now we have V0 in terms of VGS. So what I can do is I0 was how much? V0 by RD plus I2 plus GM VGS. Now if you want to calculate this current, what you can do is I2 is how much? I2 was VGS 1 plus GM RS. Oh, it was right. I2 was VGS 1 plus GM RS by RS. So I2 was minus minus VGS 1 plus GM RS over RS plus GM VGS. Okay. Now what you can do here is you can substitute, write like this, GM minus 1 plus GM RS over RS. If you take the LCM, GM RS minus 1 minus GM RS, so it will remain minus VGS by RS. So if you substitute VGS in terms of V0 now, VGS can be found here. So it is minus V0 RS. So minus minus plus V0 RS over R0 plus RS plus GM R0 RS, which means V0 by I0, that is R out, is RD parallel with, it is RD parallel with, and here one RS will be there, RD parallel with R0 plus RS plus GM R0 RS, which approximately is RD. Okay, so this expression is very complicated. When we are finding the output resistance, we have just found the output resistance as parallel combination of RD and R naught plus RS plus GM R naught RS. Now the last term that I want to derive is the voltage gain. Okay. Suppose I want to derive the voltage gain. For voltage gain, again let me go back to the circuit that I designed. It is the circuit. Now I will not show any I naught. I need this V naught. Okay. Let me remove this. Okay. So now I want V naught over Vi. Now Vi is nothing but V naught over this. Sorry, Vi is nothing but VGS plus this Vs. So what I'll say, I'll write down this equation. Vi is nothing but VGS plus Vs. Okay. Where Vs is equal to I into Rs, where I is the current through this Rs. I is this current. Now I want V naught. If I want V naught is the voltage across this RD. This current is GM VGS. This is I. So how do we proceed further? What I will have to do is, what I can do here, basically the voltage across this R naught, what will be this voltage? Suppose V. How you will write this V? V is V naught minus Vs. And what about the current here then? Suppose I dash. I dash will be V by R naught. So what I'll write? V is V naught minus Vs and I dash is V by R naught. Once we know these things, this current is GM VGS, this is I dash. So the current here will be I dash plus GM VGS. But this current is going from bottom to top. So the induced voltage will have opposite polarity to V naught. Now you can directly write V naught. So what you will write? V naught is minus I dash plus GM VGS RD. So minus I dash RD minus GM VGS RD. Now these are the equations that I have to simplify to find V naught by Vi. So first thing that I want to do here is, I want to eliminate this I dash. So what I'll do is, Vs is simply Vi minus VGS. Okay, that is your Vs. If I substitute here, so V will be V naught minus Vi plus VGS, which means I dash will be V naught minus Vi plus VGS by R naught. Okay. So from here I can say V naught is minus I dash RD. I dash is how much? V naught minus Vi plus VGS over R naught into RD minus GM VGS RD. Now in this expression there is one more parameter that is left, that is VGS. It is not a direct relation between V naught and Vi. How you can eliminate this Vs? Basically, this Vs can also be seen like this. If you see this current I is how much? GM VGS plus I dash, and Vs is IRS. Okay, Vs is IRS, where this current I is sum of two current GM VGS and I dash. So I'll write Vs is IRS I is GM VGS plus I dash. Okay. And Vs is Vi minus VGS. GM VGS RS. And what about I dash? I dash is how much? V0 minus Vi plus VGS, this I dash, RS by R0. Now what I will do here, based on this relation, okay, based on this relation, I will simplify. I will collect the terms containing VGS, Vi minus V0 into RS by R0 equal to VGS 1 plus GM RS. Okay, I am taking the terms on VGS on the right hand side plus RS by R0. And there is one more term containing Vi. So that means we can write VGS as Vi 1 plus RS by R0 minus V0 RS by R0 whole divided by 1 plus GM RS plus RS over R0. We know VGS. Now using this relation we can find out the value of V0. Okay. Now we can find out the value of V0. Or basically what you can do is, see one more thing. If you want to simplify, right? GM VGS plus I dash is I. This current is I, so this current is also I. So you can say V0 is minus I into RD. V0 is minus I into RD. This I was how much? GM VGS plus I dash. I dash was V0 minus Vi plus VGS by R0. Okay. Or you will again get back the same equation. So let us simplify this. V0 minus V0 RD by R0. Okay. Plus Vi RD by R0 minus VGS RD by R0 plus GM RD. Now you can substitute the value of VGS. If you substitute the value of VGS in this expression, you will get a relation between V0 and Vi. So for approximation, what I will do now is I will assume R0 is high. So the terms containing 1 by R0 I will ignore. So I will say V0 is minus VGS into GM RD. So 1 by R0 you will ignore, where VGS will be Vi over 1 plus GM RS. So it is minus Vi over 1 plus GM RS into GM RD. So that means the voltage gain. That means the voltage gain V0 by Vi will be how much? Minus GM RD over 1 plus GM RS. So in the last step what I have done is I have assumed that the R0 resistance is very high. So I have ignored the terms containing 1 by R0. Now suppose if RS was 0, that means the resistance was bypassed. The gain would be minus GMRD. So you can see due to unbypassed resistance, the gain has reduced. That is what we studied in BJT also, that if resistance is not bypassed, it acts as negative feedback and it tries to reduce the gain. And that is the same thing that we have seen in this derivation. So if I summarize what we have covered in this video, we found out the transconductance. It was del ID by del VGS. which was Gm naught 1 minus VGS by VP. It was also equal to Gm naught under root ID over IDSS, where Gm naught was 2 IDSS by mod VP. We saw the concept of input and output resistance of a JFET. Then we studied small signal model, in which I told that the gate source terminal are open circuited VGS. Then there is a current source GM VGS, okay, in which a parallel resistance R0 is connected. This is your source terminal, this is gate terminal, this is drain. So based on this model, we have derived the gain. So I showed you that when RS is bypassed, the gain is minus GMRD. You don't have to memorize, you just need to remember the circuit. And when it is unbypassed, the gain reduces, it becomes minus GMRD by 1 plus GMRS. Okay, so RS acts as negative feedback. So in the next video, what we'll do is we'll take a look at some more configurations and we'll derive the same amplifier parameters for those configurations as well. Okay, so this will be all from this video. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2 year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these two channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.